So this next introduction gives me the opportunity to steal a line from David Letterman, and you don't have that very often as a journalist. My next guest does not need any introduction, because he's Professor Gerhard Fettweis, whom I think everybody in the audience will know. And he's one of the key reasons, I think, why we're here in Dresden with our Connect conference. We've known each other for years and centuries now, and had always a very close relationship in terms of understanding technologies. And what I learned as a journalist in these last 10 years, 15 years is listen closely to what Gerhard has to say, then you have a good look into the future.
Hi. Thank you very much. So I would say, think of this presentation more as a think piece than as a presentation. Yes, I want to inspire you to start thinking about our future, about opportunities, and maybe missed opportunities if we don't think good enough. Let's start thinking. What is one of our values? One of our values in Europe is clearly trustworthiness. It's the basis of democracy, it's the basis of our daily life. And if we look at trustworthiness, and we did a study for the BSI, for the Cybersecurity Agency, which is located here in Freital. Probably another good reason why they're here is because there are a couple people here. We did this Open RAN risk analysis. They asked us to do it on trustworthiness. Now, what is trustworthiness? It's a couple parameters, and we looked at not all 7 of them, but at least at 5 of them: confidentiality, integrity, authentication, availability, and privacy. These are clearly different elements to build trust in a system. And trust is really important. So if you want to build trust in your banking, you want to certainly make sure it's private, it's authenticated, that you're really talking to the bank with remote attestation or other kind of availability would be nice, but if you cannot do your banking right now, you might do it in half an hour. And confidentiality is also important. So there are different aspects of trustworthiness. Now, what we see is our cellular network really falls together. Because what you see here is red dots, and we see what happens if I try to attack it from an outsider, user, insider, cloud operator, or RAN operator. And you see the C is a confidentiality, I is integrity, A is authentication, Z is Zurechenbarkeit, yeah? And P is privacy. So we see that 5G is always one column, and the left of each of those 2 columns and everything, and the right one is ORAN, and we see it just falls apart. And if there's a little plus in these red marks, we found a way to hack into the system. So what is the problem? We've designed our networks for functionality. Me, myself, I as well. Yes, functionality is fun. Yes, have a car with more horsepower or nicer way of driving around corners. Functionality is fun. But if we don't believe our car can be trusted, but it's going to lose a wheel or whatever, it's not so much fun. And we have not been thinking in those terms in cellular. And why is that now so important? Let's look back. 1G, 2G was voice telephony. Both voice. Why did we need 2G? 1G was addressing business customers, and we said, consumers don't need cellular. Consumers have cordless telephony. Good enough. Remember those times? If you're old enough, you do. Telepoint. Remember that big Telepoint study in Dortmund, the Birdie project? Anyhow, then came 2G, told us, it's for consumers, guys. This is a different story. Then we said mobile internet, very cool new feature. And what was it? Only for business customers in the first generation, in 3G. And we said, remember those times? Bernhard Walke, my colleague of Aachen, published, Wi-Fi is going to kill cellular. We don't need anything, because Wi-Fi was handed out to consumers at the same time in the first decade of this century. And laptops and Wi-Fi were great at home, in offices, whatever all. I love working on sitting on the sofa with my laptop. And there were big fights. We don't need anything for consumers. Wi-Fi is good enough. And we found out we can shrink that phone, that laptop into a smartphone. And 4G was for consumers. Now I talked about trust, but now we're at the era of 5G. Now we're connecting robots, real and virtual elements, into our system. It's all about addressing verticals. We're running 9 networks here, campus networks. We have 180 use cases collected. So Hakan, the two of us should talk with all kinds of different parts. Yes, we're in the BMW manufacturing plant. We're in DHL Leipzig. We are in the airport. We're in the chemical plant. We're all over the place. In a hospital. We're in the Weingut Poschwitz. We're in Sachsen-Obst. We're in all kinds of different scenarios, in a hospital as well. Construction site, flying drones. We have all these use cases. It's all business. Nothing is consumer. And what have we learned in 3G? You cannot earn money as an operator if you address business customers. It's just a little bit. The fun starts with consumer. So what is going to be happening, and what we're seeing now, again, we're teasing, we're whetting the appetite of consumers with personal mobile robots, and with a little bit of virtual reality coming soon now, with the new glasses coming out this year. So home robots, vacuum cleaners, lawnmowers, whatever all, and it's going to be huge, starting with 6G. It's going to be absolutely huge. It's going to change the way we do entertainment, gardening, our daily chores, our mobility. We'll have little chairs that we sit on. Wheelchairs will become our mobile kind of units. Everybody walks around with hearing aids. We call them AirPods or whatever. Yes, today. So why not wheelchairs? Yes. It will change our health, our fitness. We'll have personal companions telling us how to walk. Our gait is not right or whatever all. It's going to be fun. And what does that mean? It's not moving from one cell phone to another. It's actually taking robots that we're trying out right now and basically all over the place, yes? Like exoskeleton and others. This is from, by the way, when we still had CeBIT. Based on my crazy ideas already then, we tried out with exoskeleton, and we could have this person that is physically impaired completely walk and run around with exoskeleton. So it's really about this personal mobile robots, motion control of real and virtual objects, and motion goes consumer. This is what 6G is in my way of thinking. To be able to do that, we really have to drive down cost. Cost. We have to drive down energy. Going from 4G to 5G, we typically have a 3x increase in energy consumption. We have to drive this down by 3x over 4G. So we need 10x less, but at 100 times higher data rate means 1,000 times less energy per bit. We're working on that, don't worry. We need trustworthiness, and we need new functionality, because these robots, of course, they're not supposed to be spies. They have to be sensing, radar sensing, in some way, and spectroscopic sensing. Finding out, is that what is in the way, something I can push aside, or is it your Chinese Ming vase that would break? And building in this, so sensing as a service, because we send out radio waves for data communication, so we can also use this for sensing. We don't need to put in a separate, expensive radar system. That's the whole idea. But I spend time with the executive VP of Google and of Apple, two of the ugly five, as my friends in the Bay Area call the 5 big companies. What is their interest? They want to use that to spy on us. They love this idea. Why? They want to spy us in the kitchen. They want to see what we eat. They want to look at our kids' room. Is it tidy or not? They want to know how we live. Is it messy or not? Yes. They want to sense our skin, spectroscopic scan of our skin. What do they want? They have figured out there's a 10 times bigger business case than both of them what they're doing right now if they get into the health business. If they find out everything about you, how toxic is your paint, what is your eating habit, what is your life habit, then they can take out the whole business of life insurances, health insurances, everything, and do it themselves. And that is 10 times bigger than what they're doing today on a worldwide scale. So that's why I just put this color thing. Just think of anything that they're going to be doing, spying on us. And you're going to happily download this app, accept all. Nice. So it's about trustworthiness. And this joint communication sensing, which we really need, is the biggest attack coming. And I have to say this because joint communication sensing was an idea I proposed here 5 years ago in Dresden at our 5G summit. And the whole world is. There are more than 10,000 researchers working on this now. So if we think of this, we think of trustworthiness in a much different way. So now the question is, how do we make sure that we really isolate? Because we have to isolate identity, location, my personal position, sensing parameters like radar sensing, radar imaging, spectroscopic imaging, my data. All these things have to be separated. And I am not going to be allowed to select all, accept all, and Google and Apple can overdrive that, because that's a flaw in GDPR today. GDPR is great, but it says every user is allowed to override everything, and this is what these guys, the ugly five, are using. So the idea, therefore, is to say, if we think in our European way, what need we really do? And so we really have to come up with the hardware to really build this. A friend of mine, Werner Haas, from one of the cool cybersecurity companies here in Dresden, he's one of the guys that found out Meltdown and Spectre. Yes, there were two guys, one in the US and Werner Haas. And so if you talk to him and find out, I mean, the issue is you have an Intel building a chip platform, you have a Microsoft or a Linux, an operating system, and they're completely separate. It's like Teflon sitting on top, and no wonder it doesn't work. So how do we build a computing architecture for the Internet of Things that really builds this trust? But we have to think of, in our ways, of our industry. It's not computer architects that can do this, because it is camera processing, radar processing, geolocation processing, spectroscopic processing, LiDAR processing, all these different things. Yes, it's not just a computer, it's a robot. It is the communication, all the different parts of communication, all the different apps that have additional accelerators like neuroprocessors and other kind of things. And then the management of the whole. So what we really need to make sure is that we can isolate this from the bottom up. Now think of one antenna that has joint communication and sensing, one RF circuit, one A to D converter. That's bad. That's not what we want. We want to make sure that even in the radio front end, we can take these things such way apart that they're isolated, maybe even encrypted with homomorphic encryption, separated, so that an Apple, if they say accept all, but they don't get the key from some agency to really combine these, you can still say accept all, but you don't get all. So this is the idea. Only this way can we really make sure that our true European values are kept. Now, as I said, it's amazing because we have to go from the antenna all the way to the power amplifier, low noise amplifier, RF subsystem, the whole system, all the way to the computing part. So the computing is important. I'm not saying it's not important, but the front end is important, the mobile terminal side, the base station side, and the mobile edge cloud. Everything needs to have these kind of isolation mechanisms. And so every one of these has to be wrapped around with some isolator and some trust point in the bottom right here that makes sure that we can actually have these things. So the approach is now to see how can we do this? Because if we can build this kind of a chip platform, we can truly do what Honecker loved doing, überholen ohne einzuholen. Yes, then we can actually provide chip platforms that go beyond what a Qualcomm or others can provide today. So we need a trustworthy processor and system interfaces. And this is like, I mean, we've done processor design. If you have an iPhone 7 and above, if it has 4G, it's a 20-core subsystem built by one of our startups. How do we build the trustworthy operating system, really clinking into that, so that we can have the whole software system built on top? How do we also have the wireless interface, because that's the other major attack point of such a computing device and an IoT robot, so that connects to the internet. And that's why the government here in Dresden, in Sachsen, gave us the opportunity. 4.5 years we started the Barkhausen Institute to exactly research on this. And we've taken this now onto a European scale with the COREnext project. Why is it so important? Because think of it in sociology, political senses. Up to 1450, before Gutenberg, we had manual labor. Everybody, we needed 2 people working at home and somebody still being a slave. We had 1% class of the haves. Yes, der alte Adel were the slave drivers. They were not called, if you read German history books, it's not called slaves, it's called Leibeigener, because the historians are typically nobility, so they don't want to be quoted as slave drivers. And we had autocracy. Then came 1450, Gutenberg, the Big Bang, the invention of mass communication. And suddenly we had literacy. Slavery was, with some hubbles and bubbles, yes, in the whole first Renaissance, and with empowerment, and the outcome was the middle class, finally in the last century, with democracy. Now we have another Big Bang. We have mass communication going to global communication because we have the World Wide Web. Now we suddenly, nobody wants to have a slave anymore, an employee, because I can't have a robot. I'd have to deal with the personnel issues. Yes? Who wants to have somebody cleaning your house if you can have a robot do that? So it will be much more equal. It's a huge boost in economy. We'll have a broad class that can do this, and we'll have to develop our democracy in some kind of new form of digital democracy. That is clear. And if you talk about what kind of robots could appear, I just click through this. I'm not going to even read this. These are just some ideas that we came up in some kind of a brainstorming session, just to give you an idea of all the different kinds of robots you can think of. It will change Adidas, Puma, it will change Bosch, Siemens, Hausgeräte, Gaggenau. It's going to change everything you can think of. Yes, so all these different areas will be robotized. The great news is, in all these areas, Europe is leading in consumer products. They're not consumer electronics yet, but they will change into consumer robotics. What do we need? We need knowledge on robotics. We need to know things about wireless, sensing, AI, computing, chips, fabs. We need life cycle management, because these robots, if they cost 3,000 to 4,000 euros, people want to have them repaired. When we moved to San Jose, our dishwasher broke. I called up the landlord. We need a repair service. He said, Gerhard, it costs $199. We don't repair, we throw away. In my little house in Berkeley, everything is Bosch. We bought a house, and of course in Berkeley, people don't buy anything below Bosch. Yes, and for Bosch, even in Berkeley, you can get repair service, yes. So if it has a certain quality, and these robots will have that, we need this whole lifecycle management, and of course ethics of privacy. Good news is, these 6, Europe is a stronghold. We're the biggest in sensing chips, in sensing systems. We're super good in robotics. We're super good in wireless. We're super good in chip fabs, if we get the Intel fab finally built, and lifecycle management, and of course the chip fabs we have here in Dresden. So we're really in a pole position. If you look at those ingredients, hardly any other place on planet Earth can put 6. Most of them have 4 or 5 strongholds. So really, for personal mobile robotics, we're in the pole position. So with that, we have to enter this chip platform era. And that's why we built this COREnext project with 23 partners in 10 countries, with Ericsson, Nokia, Infineon, NXP, and all the likes. Every player is participating to do exactly what Honecker dreamed of, yes? But with the right ingredients. I think, because you cannot just, if you're trying to catch up, you cannot pass. But if you have the right ingredients, we think we have them, and so that's what I want to give you. this think piece of all these opportunities and what we have to do to get our act together. Thank you.
This guy is always good for a surprise. I did not expect to hear something positive about Europe's position in the world when it comes to digitization, but good to hear. I could imagine we have a couple of questions. One in the front.
If I got you wrong, you talked about trustworthy CPUs or trustworthy systems. Isn't there a danger that nobody would provide services to such a trustworthy CPU because, yeah, let's say Google, one of the ugly five, wouldn't want you to succeed with such a device? And if you don't get the services, you don't get the functionality, it would take the fun out of it?
Let's take, for example, Google Maps. Yes?
Yeah.
If I open Google Maps to go somewhere, I have to disclose my position, my location, where I am and where I want to go. But actually what Google does is, for many reasons, they also grab your identity. And this is illegal according to GDPR, unless you personally have said, I'm fine with it, which you do with accepting all these conditions. But for the service itself, you don't need that. If you use MAPI, for example, the Czech app, which I do a lot, they don't do that. Okay, they don't track your personal identity. So, and they use OpenStreetMaps. So if we want these levels of services, we don't necessarily need these. And these companies, if we put in the right regulation, will be forced to think that way. It will be a give and take. If it's a free-for-all, then we're in the issue of the companies taking over, these kind of companies taking over, and there's certainly new ones going to pop up in this era. And putting in the right boundary conditions is something our industry has been playing around with plenty of years. In telecommunication, from the infrastructure side, everything is regulated. So regulating a little bit on the app side, I think, is not a big issue. We have to do something.
More questions?
I understand that you ensure the security in the system as long as you stay within this ecosystem of your new designed devices and platforms. But how can you avoid to compromise the elements in the network that exist outside of this by carelessly designed devices as it is today, like cheap robots, which are kind of not only a backdoor, but a wide open front door to the whole system?
Well, it's not only a robot. Once upon a time, we started a startup, a big data analytics startup, and we had an app where we could measure network performance, just like Håkan was talking about earlier. And if you downloaded our app, we said, oh, we can also measure eyeball time on how long you're working on Facebook, whatever else. So we could build a cockpit and sold this to multiple different network operators to make sure that they understand what's happening, where are their handover issues, to do network performance optimization. At the same time, we had a great marketing tool. And then we found out, oh, we can actually track, because the different CEOs of European network operators loved it, they downloaded it, we could track their position. Yes? By less than 10-meter accuracy. And I stepped in right away when I found this out, that we could do this, and said we have to put in place a system that we don't even think our system ever is capable of tracking that. And then we looked at different apps, and we could see that some pocket calculator, for example, downloaded everything on your phone to North Korea, another app downloaded everything to Russia, another one to China, etc. So there are interesting free apps, especially in the Android world, that have side effects today that are interesting. Now, to put it that way, what your question is, will I be in a system where rules and regulations are hindering me? If you think of it this way, Libya is a failed state at this point in time. Still, Germany is not a failed state at this time. So we can live in a society on a globe where we have components that are untrusted, even though this whole system doesn't fall apart. So the question, therefore, is if even political scientists have been able to do that, we as engineers should easily be able to do that, and there are methodologies to do that, of tunneling and whatever, all to make sure that even in an environment with untrusted components, we have trusted zones. So we just taped out a chip 3 weeks ago with our first trusted-based computing platform with microkernel architecture with a trusted operating system. And so we're trying to make sure that we can get this to a point that we can have untrusted third-party components that are isolated on a chip, because we have to put in IP on these big mega chips. That is untrusted. Still, it doesn't compromise the rest of the chip. And what we can do then, trying out on the chip, we want to take to the system and then to the network. So yes, we have to take one step at a time, and we'll find some surprise problems, but we're engineers and researchers. We'll find a solution. We don't have them all yet today, honestly. It's a good question.
I would take that as a conclusion. Professor Gerhard Fettweis. Sure. So next up is the well-deserved coffee break.